Hi, my name is Paula Moraga Baez, and I'm going to be going over the Panchromatic HST Wide Field Camera 3 imaging study of NGC 7027. So some background on this planetary nebula. This is a young and rapidly evolving planetary nebula with a very unique shape. The four lobes, the elliptical shape in the center that you can see here, and also the dust belt that surrounds its waist. It has a very hot central star of around 200,000 degrees Kelvin and molecule-rich gas surrounding it. Although numerous studies have been done on NGC 7027, I wanted to focus on the studies that looked at the molecular velocity channels of this nebula to be able to distinguish the outflows that exist here. And the one that I want to call attention to is what is labeled as outflow 1 here in this figure. This is just a brief overview of the program for the images that were taken of NGC 7027. So here you can see that we targeted some forbidden lines, some recombination lines, and also the J and H band continuum. The full suite of the HST Wide Field Camera 3 images shows how the morphology of this planetary nebula changes as you move from UV wavelengths to optical, where you start to see those rings around it, and then to near IR wavelengths, where you primarily see that elliptical shape in the center. Here are a few line ratio images. I wanted to focus on sulfur 2 and iron 2, which are used for tracing strong shocks that can occur in nebulas. So here I have placed together an H alpha over H beta image in red, sulfur 2 in green, and the iron 2 in blue. And you can see how the sulfur 2 and the iron 2 nestle in very well with each other, indicating that this would be a region where a strong X-ray emitting shock would be occurring. So now that we have been able to qualitatively distinguish where shocks can occur, we wanted to see if there was something quantitative that could be done. And so what was done was an excitation diagnostic diagram was created using the sulfur 2 over H alpha images and oxygen 3 over H alpha. In these papers that are listed below, a line was defined to be able to distinguish between fast low ionization structures or fast shocks and photoionized regions, which would lie below the line. These pixels were mapped in an H alpha image that you can see here on the right. And essentially what is red would be considered a fast shock, and what is blue is photoionization that is occurring. This just happens to coincide very well with the image that was previously shown with sulfur 2 and iron 2. Something else that was done was the measuring the extinction of NGC 7027 central star. And so what was done was flux points were calculated for 9 different wavelengths using these images. Then a 200 kilokelvin white dwarf model atmosphere was plotted in blue. And these flux points were then extinction corrected for a range of extinction coefficients. And the best fit was determined to be 2.80 plus minus 0.13. Next, a 198 kilokelvin black body was compared to both the model and the corrected flux points and integrated to give a luminosity of 6 × 10⁻³ solar luminosity. So that just briefly summarizes some of the work that has been done with the data that was collected. I hope you enjoyed this, and thank you for watching.